All right, kids, here we go. Here we go. This is going to be the Algebra 2 Common Core. Now, if you want, this is going to be, by the way, my name is Mr. Key. I'm not sure why I'm using black. That's kind of boring. Well, let's go to blue. This is going to be part 1. These are part 1 questions. And this one is part 1, 13 through 24. They take forever, so I need to break them up so I can upload them a little bit easier. So this is parts 1 through 4. You can always go to www.nkinfinity.com. Right now these aren't up, but they should be up shortly. YouTube them. In the show notes should be video or links to the other videos. You can always go onto my YouTube channel at Kendrick Krause. Anyway, good luck. Let's see how you did. Let's see how we did. Again, we're going to start with problem 13. We just did view. Let's go page width. We just did that problem. Okay, so a Ferris wheel at a landmark, Navy Pier in Chicago, takes 7 minutes to make one full rotation. Totally useless information, but that's okay. The height h is represented by this equation. All right, so it's a sine function. And you should know all the pieces of the sine function. Amplitude. This is going to be right here, my frequency. This is a shift. And this is my midline. So if you were graphing this on a graphing calculator on your graph paper, although it would be very difficult to graph, this is where you always start. You always start with your midline. So I'm going to go up and start 10, 20, 30, 40, 50, 60, 70, 80. Oh, that's terrible. Let's try that again. 10, 20, 30, 40, 50, 60, 70, 80. This is my midline for my graph. Okay? Now, it is a sine curve. I don't care about the fact it's got a phase shift, because the only thing they're asking about is what is the minimum height? How close to the ground is really what they're asking. What is the minimum height of this graph? Well, we start at the midline. We drew this in at 80. And we're going to then use the amplitude. Well, what does the amplitude say? Well, it says we're going to go up 70 and down 70 and up 70 and down 70 and up. I don't have to keep going. If I go up 70, I'm at 80 plus 70, so my max height is 150. If I go down 70, I'm at 80 minus 70, and my minimum height is 10. They want minimum height. Minimum height is 10. And that's all there was to that problem. A little bit of reading. All right, so the next question. The expression blah, blah, blah is equivalent to. I'm going to do this problem 2 different ways. I'm going to use the calculator and I'm going to use my brain. We're going to use our brain first. So the first thing we're going to do is we're going to divide 2x plus 3 into 4x cubed plus 5x plus 10. I don't know why I wrote 10 like that. All right, let's do this. How many times does 2x go into 4x cubed? Oh, 2x squared. All right, good. How many answers have 2x squared? 2x squared, 2x squared, 2x squared, 2x squared. That's kind of boring. That's not going to help us out. So we do 2x times 2x. I get 4x cubed. 2x times 3 is plus 6x squared. Oh, this should be squared. Oh, that's a tricky problem right there, my friends. Woo! Almost screwed that up. See, this is cubed, and this is x. That's a problem. That's a problem. We have to actually put in a missing piece. So plus 0x squared plus 5x plus 10. Ooh, almost forgot to do that. That would have been ugly. Ugly. All right, because notice there's an x squared term missing. So, all right, so now I got to remember to subtract. So I'm going to subtract. So I get negative 6x squared plus 5x plus 10. I don't know why I can't all of a sudden use my touch. All right, so, oops, can't do that. So now, I might need to bring this over so my big fat head doesn't get in the way. So now we're going to go, okay, what do I have to multiply to get this? Oh, what do I have to multiply 2x by to get negative 6x? So that's going to be minus 3x. All right, so how many answers have minus 3x? Oh, only one. I'm actually done. That's the answer. I'm going to finish it just because I like to finish things. So we're going to do minus 3x. So minus 3x times 2 is negative 6x squared. Minus 3 times positive 9 is negative 9x. Excuse me. Negative 3 times positive 3 is negative 9. We're going to subtract, which means add here and add here. This gives me 14x plus 10. What do I have to multiply 2x by to get 14x? That's plus 7. 7 times 2x is 14x. 7 times 3 is 21. Subtract. I get negative 11. So my answer is that minus 11 over 2x plus 3. Because that's the remainder theorem, right? Ah, there we go. Now, that's one way to solve that problem. And you're probably going, wow, Mr. Krause, that was really easy. I can do that. Well, here's another way to do the problem. You knew I would. Let's take any number. How about 2.31? And we're going to store it into x. Doesn't matter what number you pick. Don't pick 1 or 0. Try to pick something bigger than 2. Don't pick anything ginormous. Then your problems. Then you got all the other issues. And then we're going to type in the original. The original was control division. 4x cubed. Get out of cube mode. Plus 5x. Plus 5x plus 10. All over 2x plus 3. 2x plus 3. Hit enter, and you get that obnoxious number. Now, I can go through all of these, but since I know this is the right answer, I could go through all of them. None of them will work except for this one. I'll type this one, 2x squared minus 3x plus 7 minus control division 11 over 2x plus 3. Hit enter. Look at that. They match. There's our answer. All right. So this one was designed to trick you. Okay? Because we teach you some cool stuff about math, but this problem actually had two problems in one. So my guess is many of you thought you got it right, but you didn't. And I apologize. This is a tricky question. But you still should have gotten it right. I know that if I have exponential decay means if I have my function, it's my starting amount, start, my base to some exponent. And the key thing about the base, this thing right here, is it has to be between 0 and 1. It has to be a fraction, which is why so many students picked this answer. And that was the tricky part. Because you might think that's correct, except that it had a negative exponent. And so that's the second part of this exam. A negative exponent, if you have 1/2 raised to the negative 1, that's equal to really 2 over 1 to the 1, or just 2 to the 1. So now it becomes not a fraction, it becomes an integer. So because of that negative, this is equivalent to 2 to the t, and that's exponential growth, not decay. So the right answer is this one. Because this 5, because of that negative, that turns that 5 over 1 into 1 over 5 to the positive t. And that is a exponent rule as well as now an exponential decay question. However, why do I say you still should have gotten it right? You still should have gotten it right because you could have gone over here to your graph mode and said, okay, parenthesis 1 divided by 2, parenthesis, raised to the negative x. Enter. That's growth. That's an exponential growth question. And then you could have gone, okay, tab. Oh, it's not gonna, let's go doc B. Then you could have gone back in your graph mode and said, okay, how about 5 raised to the negative x? Oh, Yeah, that's exponential decay. You still should have gotten it right because you still have to have more tools in your tool bag. You can't just rely on one trick. You got to be able to use all of your tools in your tool bag. And in that case, using the graphing calculator really would have helped you out. All right, let's move on. Page 7. It's a tricky question, I'm not going to lie, it was, but it was doable, and you guys got to learn to do things more than one way. Inverse functions. I'm going to show you 2 ways to do this one. Okay, one way and then of course, using the graphing calculator. So really what I have here is y equals negative 3/4 x plus 2. Now they tried to trick you by giving you the inverse and asking you for the original. Like that's different than giving you the original and asking for the inverse. The process is done the same way. It doesn't matter if they give you the inverse and they ask you for the original, or they give you the original and they ask you for the inverse. It's done the same way. To find an inverse, you first switch the x and y. Okay, switch the x and y. X equals negative 3/4 y plus 2. Now I hate that 4. I'm going to get rid of that 4, and I'm going to do so by multiplying everything through by 4. This is just a trick that I teach all of my students. Get rid of fractions because we hate them. So this gives me 4x equals, now these 4's cancel, negative 3y plus, and that's a 4, 8. So I'm almost there. I'm going to bring the 8 over, so I get 4x minus 8 equals, careful, negative 3y. I still got to get y by itself, so I divide by negative 3, divide by negative 3, and I divide by negative 3. 3. So my answer is, and I'm running out of room here, so I'm going to try to do this in a green. My answer is negative 4/3. Every time I draw a 4, it looks like a 9. Negative 4, that's this, over 3x. And then here, 2 negatives make a positive, so plus 8/3 equals y. And that, my friends, is right there. Now, I promised you I'd show you 2 different ways, so let me show you the other way. So I'm going to go over my graphing calculator, get rid of this, Doc B, and I'll get my graphing calculator. I'm going to type in the original, which was negative 3/4 x plus 2. So negative 3 divided by 4, tab, hit the up arrow. Doc B, I hate this. Why is it doing that? All right, so tab. So negative 3 divided by 4x plus 2. That was the original. Boom, there it is. Now, let's type in, hit tab button. Let's type in what we got. We got negative 4 divided by 3x plus 8 divided by 3. Enter. Now, in order for them to be inverses, they have to be reflections over the line y equals x. So I'm going to type in one more line. I'm just going to type in the line y equals x. Do those look like they're reflections? Okay, this one's kind of tricky, you know. If you reflect this blue part here over this line, doesn't it give you this part over here? And if you reflect this blue part here over that line, it does. That's kind of a tricky one to do graphically, I get it. All right, so this next one was, man, this was not, it wasn't actually a hard question, but the way they asked it was redunculous. All right, so let's see what we got here. Did I tell you what the answer was? That last one was 2, right? Or was it 3? It was 2. Okay, we're moving on. All right, I want to apologize. I think my voice and my audio and my visual got off a little bit there. It wasn't too bad, but that's what happens when I go too long and I record too long. So I got to stop every once in a while. So let's see this. A circle centered at the origin has a radius of 10 units. So centered at the origin has a radius of 10. All right. The terminal side of angle theta intercepts the arc in quadrant 2. So I need to draw in, maybe I should do this using black. I need to draw in angle theta, and it terminates in angle in quadrant 2. So this is angle theta. So if I drew this, there's my angle. It says it intercepts the arc in quadrant 2 at point C. The y coordinate at point C is 8. What is the value of cosine theta? Well, here's a couple of things. First of all, I'm in the second quadrant. So I know that cosine is negative in the second quadrant. So those can't be true. All students take calculus. Only sine and cosecant are positive here. So I know that it's got to be one of those two. So now I want to figure out what the x value is. Well, I do that using right triangles. To get this distance here is really the y value. That's 8. They just told us that. They also told us that the hypotenuse was 10. Well, therefore, I know that this is a 3, 4, 5 right triangle, so this has to be 6. Now, some of you are like, what the heck are you talking about? Let's make it x. So we'll do x squared plus 6 squared equal, x squared plus 8 squared. I'm just going to use the Pythagorean theorem is equal to 10 squared. All I'm doing is the Pythagorean theorem. It's a right triangle. I can do that. So x squared, let's say I don't know this is 6. X squared plus 8 squared equals 10 squared, or x squared plus 64 equals 100. Subtract 64 from both sides. I get x squared equals 36, or x equals 6. All right, so this is 6. So now here comes, you got to have a little confidence in your trig. Let's go purple. If this is theta, this is the reference angle right here. We'll call this the reference angle right here, because this value here is going to be the same value as here, except it's going to be negative. So I'm in the third quadrant. So cosine is negative. Cosine of theta is equal to adjacent over hypotenuse. So the adjacent being 6 over the hypotenuse being 10. So I want it to be the cosine of theta is equal to 6 over 10, but we're in the second quadrant, so it's negative. And 6 over 10 reduces to 3/5. Not an easy problem. All right, here's one of those false questions. Here's one of those silly false questions. And I think the easiest way to handle this one is just to graph it. I think the easiest way to handle this one is just to come over to your graphing calculator and now graph it. Now, would I expect all of you to know, hey, this is log base 6, all log equations go through the point 1, 0. There's the point 1, 0, and they look like this. I would expect that you know this information and that you say, okay, that's a log function. It has an asymptote and I'm not moving it. It didn't go up, it didn't go down, it didn't go left, it didn't go right. It's just log base 6. Now, could you graph it on your graphing calculator? Oh, sure. I could say, okay, I'm going to graph control log, control log base 6 of x, and press enter. There it is. I can graph it, but it's just going to look like this. So, does it have an asymptote that's y equals to 0? Y equals 0 is this line right here. Does it look like it's approaching that line and not touching it? No, that's your answer. There's your answer right there. Now, what is the asymptote? The asymptote is right here. It's the line, this line. This is my asymptote. That's the line x equals 0. So it's kind of tricky. Remember, this is asking which one's true. Does it have a y-intercept? It's not going to cross the y-axis, so that's true. The domain is the set of all positive. Domain starts here and goes that way. All positive, yes. Is the range all reals? Yes, it goes forever and ever down. It goes forever and ever up. So the answer is choice 1. Wow, this one I thought was kind of a tricky question. I'm going to pause real quick because I got to save so that my voice doesn't get messed up. All right, here we go. So, kind of a tricky question here. I'm not going to lie. Got some issues going on here. Let's look at it. we're going to do completing the square on this puppy. We're going to do completing the square. So I've got 4x squared minus 24x plus 4y squared plus 72y equals 76. So on the left side, I'm going to factor out a 4. I'm just going to take out a 4. So I'm left with 4 parenthesis x squared minus 24x plus 4, oh, excuse me, I took out the 4, y squared plus, okay, 72 divided by 4 is 18y equals 76. All right, I'm going to do completing the square on this right here. It's going to be a little tricky. So, I don't think 24 is what I wanted here. That was the thing that was screwing me up earlier. This should be, taken out of 4 should be a 6. Okay, so if I do completing the square on this one, here's where the tricky part is going to come. So I'm going to go x squared minus 6x plus square plus y squared plus 18y plus square equals 76. Now, normally in my class, I write plus square. Hopefully my big head's out of the way. Here's the problem. Each of these squares is getting multiplied by 4. So really, I've got 4 squares and 4 squares. And that was why this was a tricky problem. Other than that, it's not bad. 4 x minus 3 squared, that's completing the square process. Half the middle term squared is 9, so 9 over here. Plus y plus 9 squared. Half the middle squared is 81, so 4 times 81. So on the left side, if I redistribute that 4, I get 4x minus 3 squared plus 4y plus 9 squared equals 76 plus 36, that's this, plus 4 times 81, that's 324. And I think if I add all that up, I'm going to get this problem right here. Now, how could I have done that a little bit easier? I could have just gotten rid of the 4. It changes the problem, but I could have gotten rid of the 4. Divide this side by 4 and divide this side by 4, and I get x minus 3 squared plus y plus 9 squared equals, what is that, 109? 109. And had I done this and gotten rid of the 4 and all these on both sides, I'd end up with x squared minus 24x plus square, not 24. Shoot, I keep doing that. Minus 6x, remember I'm dividing everything by 6, plus y squared plus 18y plus square equals, let's see, 76 divided by 4. Oh, I did 72 divided by 4. Oh, 76 divided by 4. This is 36, 18. This is going to be 38, 19. So this is 19. So if I do that, I get x minus 3 squared. I still got to put a 9 here, plus 9 here. And then I put plus y plus 9 squared, 81, right? 9 squared is 81. Put plus 81 over here. And then if I add all this up, I get 109. So that's another way to do it, having gotten rid of the 4. Still kind of a tricky question. Okay, there was a study done on oxygen consumption of snails. All right, you scientists out there, we're studying the oxygen consumption of snails. In German, it's Schnecke. As a function of their pH, which is, I think, their acidity, but I'm not sure. And as a result, The result was a degree 4 polynomial. See, this is what really killed me about this test. It was a degree 4 polynomial whose function is below. All right, so it's a degree 4 polynomial. Yay! Big deal. Starts here, ends here. Which statement is, oh, here we go again, incorrect. Not correct, incorrect. The degree of the polynomial is even. They told you it was 4. That's even. That's wrong. Or that is right. By the way, how could you have told me otherwise? It's going in the same direction. Remember, even functions look like this or whatever. They look upside down or right side up. Odd functions go in different directions. So how do you know an odd from an even? Evens go in the same direction, both up or both down. Odds go in opposite directions. So that's how you could have told you if they didn't tell you it was degree 4 and just tell you that. There's a positive leading coefficient. So you all should know if I graph x squared, it looks like this. And if I do this, negative x squared, you all know that's a reflection in the x-axis and it comes down. This is coming down. So that means the leading coefficient in my mind is negative, not positive. Florida's calling. I don't know what about. End call. Goodbye, Florida. I don't know why Florida's calling me. Sorry about that. I didn't mean to have my phone out there. Oh, now I'm getting all kinds of weird stuff. All right, so I think this is the right answer. I think the leading coefficient is negative, so it is incorrect. At 2 pH values, there are relative max. Yes, right here. Relative max, relative max. Those are my 2 relative maxes. So, yes. Are there 2 intervals where the function is decreasing? Yes, it's decreasing here. And then it starts to increase, and it decreases here. So that's true as well. So again, another tricky question. Thank you, New York State. Now, of all the tricky questions, this was by far the hardest question. Most people got this wrong. Most people did. Most people are going to pick, they say, okay, we've got, let's see, what is this? We're increasing by 5.2% over the previous year. So most kids said, okay, I'm going to do it like this. I'm going to say, I know an increase has to be 1 plus a percentage raised to an exponent. And they're going to go, okay, the percentage is 5.25%, so that's 0.0525. And you might have picked, oh, to m, and picked that one. No, you'd be wrong. Oh, wait a second. They said something about months. So maybe I divide by, maybe, oh yeah, wait, maybe it's not m, it's 12 over m because it's 12 months, 12 over m. And you pick that one. No, you'd be wrong. So where in the heck do these answers come from? Well, let's see what we got. This is going to be 1 plus 0.0525 raised to the exponent. Now, the exponent normally would be months, but m is the number of, we want m to represent the number of months, so what we really need to do is do m divided by 12. So you're thinking, oh, wait a second, they must have made a mistake, 1.052, this is really, excuse me, not 1, this is really 1.0525 to the m over 12. They must have made a mistake, that's the answer. That's not the answer either. They didn't make a mistake. But they wanted you to go further, and for what reason, I have no idea, but they wanted you to go further, and what they wanted you to do is to, once again, apply the rule of exponents to try to figure out how to do this problem. This is the same as, and I don't know why they asked you to do this, 1.0525 raised to the 1/12 times m. Okay. So what they did was they said, okay, what is 1.0525 to the 1/12 power? 1.0525 raised to the, oops, that's not raised to, raised to the control division, 1/12 power, 1.00427. So this part becomes 1.0 0.0427 raised to the m power. And that's this one. Not cool, New York State. Not cool. Don't know why in the world you thought that was an appropriate question. I didn't think so. You need to put me on your testing question making up, because I would have thrown that one out and punched the person that made it. I wouldn't have punched him. I'm just kidding about that. Yes, I would have. No, I wouldn't have. So, no, I'd use my words. By the way, I just had to stop this tape and try it. I tried this problem, and I didn't realize something when I first did this. So let's check this out. This is going to be quite interesting. Watch this. This is why I think people got this problem wrong. And wow. Wow. Once again, okay, I'm going to show you two different ways to do it. I'm going to show you the mathematical way, which just says let's set these things equal to each other. So we'll do x cubed plus 3x squared. I just realized why most of my kids probably missed this one, is equal to 3x plus 8. I'm going to bring the 3x and the 8 over, so I get x cubed plus 3x squared minus 6x minus 9, right? I'm subtracting 3x, subtracting 8 equals 0. All right, I'm going to combine these first two. What can I take out? I can take out an x squared. And I'm left with an x plus 3. Of these two, I can take out a negative 3. And I'm left with, be careful here, x plus 3. Now your parentheses have to match if this is going to work. All right, so I have I have x plus 3 and x squared minus 3 are my roots of my quadratic. Wait, is that right? Did I do that right? Oh, no, I didn't. This is a 2x. So I can't even factor this puppy. Wow. I thought I could factor this thing. Wow. We are in trouble here. We're going to have to use our calculator, because watch this. This is my issue with this problem. If you were to do this problem, here's why this problem is hard. If you were to do this problem, if you take negative 3.9 and you store it into x, and I think they did this just to mess with my students and anybody that watches my stuff, and you go, okay, I'm going to do x. See, the reason with it is these are rounded answers. Check this out, and this is awful. X cubed plus 3x squared plus 3x squared minus 3x minus 1. Minus 3x minus 1. Enter. And then you put it in the other equation, 3x plus 8, and you get, oh my God, those things aren't even close. Boom, there's the answer. They're not right. It's because it's a rounded answer. It's because it's a rounded answer. Check this out. Watch this. We're going to put in negative 1.1. Negative 1.1 control var x. Enter. And we'll do the same thing. We'll go up to this. Enter. We'll go up to this. Enter. 4.7. Those are at least close, but those aren't right either. They're really close. So let's try the other one. 2.1. 2.1. Control var x. Enter. Go up. Hit enter. Go up. Hit enter. Those are the two equations. Man, those are like one off. They're all bad. And then this question, which is not the solution? And you're like, okay, they're all not the solution. Let's try 4.7. So 4.7, control var x. I'm just curious what this one's going to give me. Go up here, get this first equation, enter. Go up here, get me this equation, enter. Oh my God. Okay, so if you had gone through all four, that one is clearly so far away it can't be right, and so that would be the right answer. Holy mackerel. So what they wanted you to do is, well, they tried to get you to bite on that one. I didn't realize how tricky that question was until just now. Here's what you should have done. You should have typed them in x cubed plus 3x squared plus 3x squared minus 3x minus 1, enter. And then type in, hit tab button, and type in 3x plus 8, hit enter. And notice at least two of these points are pretty easy to see. If you go menu, analyze graph, intersection, get on the left side, click here, you'll notice that one's, You'll notice this one down here. If I click on that, that's negative 3.9. There's your negative 3.9. Go and do it again. Menu, analyze graph, intersection. Click here, click here. There's your negative 1.1. That one works. Now it looks like there might be one up there. Sometimes it's hard to see. This calculator is nice because if you go to menu, analyze graph, and you go to intersection, you say, okay, I think there's one up there. So I say, okay, I'm going to go to the left side, click, and then I'm going to go to the right side, click, and I don't know how far to go. Let's go way over, somewhere in there. Oh, and then it repositions for you, and there's the next one, 2.1. 2.1. That's rounded to 2.1. So the answer is 4.7, but boy, oh boy, that would have been a tricky question. Okay, just 2 problems left. The population of Jamesburg from 2013 was reported as this. So let's see what's going on here. Looks like it's growing. It's growing. It's growing. Which of the following could be recursively modeled? Could be the recursive model. Well, these really aren't recursive models. These are how you represent recursive models. Recursive models always give you the first term, and then you use the next idea, the next formula or expression to generate the next sequence. So both of them start with 250,000. I'm going to use my calculator to see. Now it looks like exponential growth. Looks like we're growing. So I'm not sure if I'm adding 937 every time or I'm doing this one. So first thing I'm going to do is go over to my graphing calculator. And I've got a mess. And I'm going to type in 250,123, and I'm going to store that in enter because recursion is easy. And then the second method says we're just going to add 937. So I'm going to say, okay, plus 937, enter. Oh, 250, 937, perfect. Next one will be 251, 874. It's close, enter. Let's try enter again. 811. It's close, but it's not exact. Let's see if the other one's closer. So we'll put, let me get rid of this. And we're going to put 2,500, or excuse me, 250,000 in one more time. And to that, we're going to say, okay, we're going to multiply by 1.00375. So 1.00375 times the answer. Oh, that's still 937. Enter. That's 78. There's 78. There's 23. There's 22. This one's closer, and this is your right answer. That's your right answer for that one. All right, finally, the voltage used by households can be modeled by the sine function. The maximum voltage is 120 volts, and there are 60 cycles, and the important part for this one is every single second. There are 60 cycles every single second. So which equation best represents the voltage as it flows through the electrical wires, where T is in time in seconds? So let's see how we're going to do this one. My equation's got to be V equals 120, and they all start out that way. Sine of something T. Here's the trick. Can I figure out this? Now remember, this is my frequency. Did it give us the frequency? Well, what it said was there's 60 cycles every single second. So that means my period is, let's see, if it finished 60 full cycles every second, that means it's going to take 1 over, my period is 1 over 60. Because I want to know what happens in a second. In 1 second, from 1 second, it goes 60 times. Well, remember, period is the time it takes to finish 1 cycle. So if it finishes 60 cycles in a second, it finishes 1 in 1/60th of a second. Okay, how does that help? Well, I know that period is equal to 2 pi over frequency. Okay, so, I know that period is 1 over 60. This has to be equal to 2 pi over frequency. Okay, so if I cross multiply, I get frequency is equal to 120 pi. Oh, that's what goes there. Because I know my frequency goes there. And therefore, the answer is choice 4. Okay, kids, that finishes the multiple choice. Lots of difficult questions, lots of doable questions. So clearly this wasn't a difficult exam, but there was some difficult problems in this exam. All right, that finishes the multiple choice. I hope you did okay, and I'll be back. You're going to have to check out another video for the other part 2s, 3s, and 4s, and I'll put those all in one video. All right, kids, check out the flip side.